Okay, so have we had any success here? Maybe one thing you want to do to start is take a look at this equation that you've been given. It's probably friendlier for you to look at it in explicit form, one that your calculator could produce, so something like that. And then that's, you should be able to get a picture going once you figure that part out. 6 over x is going to look something like this, and again, I'm just doing a sketch. This picture's to help me. It's not that I'm going to be marked on that accuracy of my picture. 2 will be somewhere about here, and 6 will look something like this, and the line x equals 6. So there's a lot of stuff happening in this picture, so here's my axes, and this is the region that I'm going to revolve. So, if we think about revolving it, it's going to go around this line. So what we need to be able to do is, think about what's going to be to my advantage here. This equation that I've been given, I could also rearrange it like this, right? There's nothing to say that I can't have this as a function on y. So it's, either way I could use shell or disk. It's about as easy for either to do the shell method or disk method, or I guess washer, but you can look at this picture, it's going to be a disk. There's no hole in it, so it's going to be between disk and shell. So what do you think? Anybody have a suggestion? Or maybe we should poll this. How many people think that disk would be the method of choice here? Okay, 1 or 2 not so confident people. How about the shell method? Okay. Well, the good news is you're all correct. It could be done with either, but I'm going to take the side of the disk method people, not just because Mark is in that group, but I'll show you why. Because here's when I think a couple steps ahead. So here's my shell method. Let's say we go into shells. Okay. Here's one of the possible bars because it's going parallel to what I'm rotating. Okay. What I should immediately notice is at some point it actually changes here, and I have to do another type of shell. So there's actually going to be 2 regions. One region here and another region here. So to do this, you'd need to, basically you'd have 2 integrals, one for each of these regions, because one of them is subtracting the line y equals 6 from y equals 2, which tells me that it has a height of 4. And then there's another region when I subtract the curve here, that is y equals 6 over x from y equals 6. Or sorry, 6 minus 6 over x. It is possible, but like I'm saying, you do need 2 integrals to do this. So if you did shell method, it would look, I guess I'll do shell method in a second, but I'm just going to compare it now to show you how disk method works. So let me clear this off, and I'll put it back to where we'll start a disk method question. And I'll show you why I like the disk method for this question. Oops, that should be a y. Okay, so there's my other option, is to do the disk method. So disk method means I'm going to go perpendicular, right? The slice that I've got there, obviously it's not going to be that thick, but it's just to remind you that that is going to have, its height is what's going to shrink infinitesimally. So this would have to be with respect to y. So this is the equation that I'd be using to talk about doing the disk method. Why is the disk method my preference? Well, there's only one integral, because for the entire range from y equals 2 to y equals 6, as I integrate from there up, it's always the same 2 functions that I'm subtracting. I'm taking this line here, which is, let's see here, this is the line, in my picture now it's y equals 6 over x, and this is the line x equals to 6. So to do the disk method, my integral is going to look like this. It's going to be pi, and I need a radius function. So what do you think? What could be a possible radius function? Sorry. Yes, I don't know. It is a 6 over y. I'm not sure why I keep doing that, but okay. So what's a radius function if I do disk method? Pi r squared, but what's my radius? Yeah, the big one minus the small one. So it's going to be 6, because now that I'm doing it with respect to y, larger stuff is on the right, smaller stuff is on the left. Right? If I was doing this with respect to x, bigger stuff is on top, smaller stuff is on bottom. But now it's right and left, so I should end up with 6 minus, I don't know why I keep doing that, 6 over y, all squared dy. And in terms of y, I can see my bounds here. I go from 2 to 6, so that means the integral is going to go from 2 to 6 as well. Okay, so the radius function, again, if you think about it, what we're doing is we're taking the entire length, this length 6, and I'm saying I don't want all of it, I'd like to remove this part here. So to do that, I have to subtract 6 over y from the original 6. Okay, so both methods work, so you're all correct if you pick the shell method on this one, but I only have one integral, it does the whole thing for me. That's why I would have chosen it this way. Okay, but not that you're wrong to do the shell method. Maybe I'll quickly do here. So it'll be 2 pi. If I was to do the shell method, then your, let's see here. Just clear some of this so I can come up with the shells. Okay, so if I was to do the shells, they're going to go parallel, which means I need to know where this curve intersects. So when y equals to 2, so that means x equals 3, I believe, here. Those of you who did the shell method, is that correct? If y equals 2, I think x equals 3 is this intersection. Yeah, is that? Okay, so the first piece, if I call this region number 1, the height of the shell is 4 for all pieces, and the radius is going to be from 6 minus x. So here's radius times height, which is 4 for all those shells, and this is when I go from 3 to 6. Then I need to add the second region, which is from 0 to 3, and this time these are the shells I'm looking at. So it's going to be, again, it has a radius that is 6 minus x, and it has a height, though, this time of 6 minus 6 over x. Okay. So again, I don't think that's the easier choice, but it still is correct a way to do this volume question.